This is part 2 of section 8.6. We're solving radical equations. What we want to do, remember, is to get a radical by itself on one side, and we have that here. And then once we have that, we want to square both sides. So if I square both sides here, and then I square both sides here, on the left, the radical just goes away, and I have x squared plus 2x plus 9 is equal to. Now over here, we have something that is trickier than you may remember, okay? A lot of people are tempted to apply this property right here, where you just take that exponent and apply it to each one. But if you notice here, this is multiplication and this is addition. That does not work. What we have is a perfect square trinomial. This is a plus. We have this case. Either you use this formula and multiply everything out, or you rewrite this as x plus 3 times x plus 3 and then multiply it out and combine like terms. If you use this formula, you square your first term, so that's x squared. You write down the sign from the middle. Multiply these two things together, which would give me a 3x, and then you double that to get 6x, plus 3 squared, which is 9. Okay. Now I have squares on both sides, so I'm thinking I need to get everything together with a 0. If I move this over to here, I'm subtracting x squared from both sides, and those cancel. Okay. So let's subtract 6k from both sides. That will give me negative 4x plus 9 is equal to 9. Now let's get the x term by itself, so I'm going to subtract 9 from both sides, and that again cancels. So I get negative 4x is equal to 0. Now if I divide both sides by a negative 4, I get that x equals 0. Now remember, 0 is a perfectly good answer in general. We, of course, still have to check it, but don't panic because you get 0. It may still work. Okay, I'm going to take this and plug it in here to see if it works. That will be the square root of 0 squared plus 2 times 0 plus 9 equal to 0 plus 3. Well, of course, this is 0 plus 0 plus 9, so that's the square root of 9 is equal to 3, and that is, of course, true. So x equals 0 is a perfectly good answer. Okay. I want to solve v equal to the square root of 2k over m for k. So I want to get k by itself. I'm pretending that everything else is a number. What I want to do is I want to get a radical by itself and then square both sides. Well, we have a radical by itself, so let's square both sides. That gives me v squared is equal to 2 over k over m, 2 times k over m. Okay, I'm trying to get k by itself. What I have now is a rational equation. I want to multiply both sides by this denominator so it goes away. These will cancel. So I have mv squared is equal to 2k. I want my k by itself, so I'm going to divide both sides by a 2. So I end up with k is equal to mv squared over 2. Since we don't really know what the values are of those variables right now, there's not really much that we can check, okay? This is the answer we're looking for. Okay. Now, the next two problems are for when, if I'm teaching this in class, I'd like to teach these, but if I don't have time, I cut them out. Because these are videos, I have all the time I need, so I'm going to work these two problems. Okay, so let's look at this. I have something like this, a radical equal to a radical. Now, I can divide both sides by a 3, so I have a radical completely alone. Or I could divide both sides by 2, so I have a radical completely alone. What I do want to point out is that it is okay if you have a number in front. What we don't want to have is an addition or a subtraction. So since I have a radical term by itself, meaning it's allowed to have a multiplier in front, I can go ahead and square both sides. What I do have to remember is that this squares the 3 and it squares the square root individually. It squares the 2 and then squares the square root individually. So what I mean by that is that 3 squared is 9, and then I have to multiply that by this squared, which means it's just going to be the z minus 1. And then the same thing happens over here. I square the 2, which gives me a 4, and that's going to be times this square root squared, which is 2z plus 2. So now I'm going to need to distribute the 9 through here and then the 4 through here. And that gives me 9z minus 9 is equal to 8z plus 8. Let's move this 8z over here. So I'm subtracting 8z from both sides, leaving z minus 9 is equal to 8. So add 9 to both sides, and we get z is equal to 17. Okay, so let's check this. This is 3 times the square root of 17 minus 1 is equal to 2 times the square root of 2 times 17 plus 2. This is 3 times the square root of 16 is equal to 2 times the square root of, that's going to be 34 plus 2. This is 3 times 4 equal to 2 times the square root of 36. This is 12 is equal to 2 times 6, and you probably see that this is true from here, but you can keep going to get 12 equal 12. So z equal to 17 is a good answer. Okay. So let's try the square root of 4 minus x is equal to x plus 2. I have a radical by itself, so let's square both sides. Okay, so when I square the left-hand side, I get 4 minus x. Now this is a binomial squared, so we need to make sure that we use the formula or rewrite it as x plus 2 times x plus 2 and multiply it out. You square your first term, which is x squared. Write down the sign from the middle. Multiply them together, and then double that, so that's going to be 4x. And then plus, you square your last term, which is 4. Okay. Now this is the first time that we ended up with a square here and it doesn't cancel out. Okay, so that means I'm going to need to factor whatever I have. I need a 0. So I'm going, and it's always easier to factor if your first number is positive. So I'm going to add x to both sides, and then I'm also going to subtract 4 from both sides. Okay, so I'm going to end up with a 0 over here. And that's equal to x squared. That's going to be plus 5x. And then those cancel, right? If I subtract 4 from both sides, those go away. Now we ended up with something easy to factor. All I have to do is to factor out an x, and that gives me x plus 5. So we set each of these equal to 0, x equals 0, and there's nothing else to solve there. Or x plus 5 equals 0. Subtract 5 from both sides, and I get x equals negative 5. Okay, so this is the first time we've had 2 potential answers. They might both be good, they might both be bad, or I might have one of each. I have to check each of them. Okay, there's no shortcut here. So let's try plugging in 0 first. So this would be the square root of 4 minus 0 is equal to 0 plus 2. So the square root of 4 is equal to 2, and you can see that that's going to be true. You end up with 2 equal 2. Okay, so 0 is a good answer. Let's check negative 5. That would be the square root of 4 minus a negative 5 is equal to negative 5 plus 2. So this is the same thing as 4 plus 5 is equal to negative 3. So the square root of 9 is equal to the negative 3, but the square root of 9 is positive 3, not negative 3. So this was a false answer. This was a good answer.